DKWP, 小攻 Abor. Your learning journey starts now. Ever felt like some problems are just impossible to solve quickly? Like trying to find the perfect route visiting a million cities without repeating any? Or cracking a super complex logic puzzle? That's the world of no problem problems. They're notorious because the number of possible answers explodes exponentially as the problem gets bigger. Your computer might take longer than the age of the universe to check every single one. It's like being lost in an infinite maze where every turn looks exactly the same. Traditional computers just stare at them, overwhelmed. So, how do we fight back against these computational monsters? Enter SRAS. Think of it as a semantic superhero. Its secret weapon isn't just raw power, but understanding. It uses something called DIKWP: data, information, knowledge, wisdom, purpose. Sounds fancy, right? It's basically about moving from just seeing data to truly grasping its meaning. Imagine you're solving a puzzle. Instead of randomly shuffling pieces, SRAS tries to understand the picture first, then figure out which pieces fit together. It uses this understanding to compress the problem, making it smaller, smarter, and even jumps across different ways of thinking to find solutions that traditional methods miss. It's like giving your computer a brain. Let's peek under the hood at this DIKWP thing. Think of it like building a tower of understanding. First, you have raw data, just facts, like numbers or pixels. Then, you layer on information, finding patterns, like recognizing shapes in those pixels. Next comes knowledge, understanding the rules, like knowing how those shapes relate. Then, wisdom kicks in, using that knowledge to make smart decisions, like figuring out the best next move. And finally, purpose, the ultimate goal you're working towards. SRAS uses this whole stack. It starts by perceiving the problem deeply, then cleverly compresses it using knowledge, and always keeps the final goal in sight. It's a beautifully structured way to think, almost like how humans tackle tricky stuff. Okay, so how does this semantic magic actually work on tough problems like SAT and TSP? For SAT, that logic puzzle, SRAS doesn't just randomly guess variable values. It uses a semantic loop, constantly checking clauses and fixing conflicts based on the meaning of the variables. It also cleverly groups variables that seem related, treating them as a single unit. That's compression. For TSP, the traveling salesman problem, instead of looking at every single city pair, SRAS first identifies clusters of nearby cities. It figures out the main route between clusters, then optimizes within each cluster. It also uses intent-driven path searching, always looking for the most inefficient parts of the current route and fixing them. It's like having a seasoned traveler who knows the best shortcuts and avoids pointless detours. The result? Solutions that can be way faster than the old brute force methods, especially when there's some underlying structure to exploit. Now, the big million-dollar question. Does this mean P equals no problem? Can we finally solve all these hard problems quickly? Well, SRAS is incredibly promising, but we're not there yet. It's more like finding a powerful new tool rather than proving the fundamental laws of physics. By using semantics, SRAS can dramatically shrink the problem space for many real-world no-problem problems, making them effectively solvable much faster. Those semantic jumps? They're like flashes of insight, mimicking human creativity. This suggests that, maybe, just maybe, the gap between P and no problem isn't as wide as we thought if we consider computation that understands meaning. It opens up exciting possibilities for AI that can truly reason and solve problems in ways we haven't imagined before. The journey continues.